solve dy dx plus 1 all over x, y equals to x, y squared. Solution. So the first step is for us to divide through by y squared. When we do that, then this is the result. We shall have y raised to negative 2 dy dy dx plus 1 all over x, y raised to negative 1 plus x now equals to x. The second step, we let z equals to y raised to 1 minus n, which equals to y raised to 1 minus, in our case n is 2, which equals to y raised to negative 1. So we are saying that z equals to y raised to negative 1. So we differentiate z with respect to x at this point, so we get dz dx, which will be equal to minus y raised to negative 2 dy dx. Now compare this equation and this one. So you realize that this is dz. The only thing that is lacking here is the negative sign. So we can multiply through by negative 1 so that we make this one dz. Therefore, the equation becomes dz dx times negative 1. Here so we have minus 1 all over x, y raised to negative 1 equals negative x. Now this equation now is in this form, dz dx plus py equals to q. So from this equation, our p equals to negative 1 all over x, our q equals to negative x. And remember, the solution of this kind of equation will be given by z dot integrating factor equals to the integral of q dot integrating factor, then dx. Now, integrating factor is given by exponent integral of b dx, which equals to the exponent integral of p is negative 1 all over x, so it will be minus 1 all over x dx, which equals to, when you integrate this, you get exponent minus ln of x, which is the same as exponent ln of x raised to negative 1, which equals to x raised to negative 1, which equals to 1 all over x. So here we are applying this concept. We know that exponent ln of a function equals to a function itself. Therefore, exponent ln of x is the same as 1 all over x. Therefore, integrating factor equals to 1 all over x. We go back and substitute in the equation. So we have z dot integrating factor, which is 1 all over x, equals the integral of q is the negative x, so it will be negative outside, dot integrating factor, which is 1 all over x, then a dx. So z dot 1 all over x equals to x, and x will cancel, so it minus integral of dx. So z over x will be equal to minus x plus a constant of integration. So z equals to, you multiply both sides by x, so it will be equal to zx minus x squared. But in an equation we didn't have z, we just introduced z to enable us solve this equation. So we go back and substitute z. Remember, we had said that z equals to y raised to negative 1. Therefore, we shall say that this equation is y raised to negative 1 equals to cx minus x squared. Therefore, y will be equal to cx minus x squared raised to negative 1. Thank you for watching and listening.